Doing today? Yes, we are back to the AWS Community Series. Um, I know it's been a while. I've shown my face here, but of course, know that I'm always with you in spirit. So, I mean, if you are joining us here, please, I'd love to know where you're joining us from. Um, so, please, can you let me know your name, where you're joining us from, and then yeah, I can properly welcome you to the event for today. Yes. So yes, use the chat button. Let me know your name and where you are joining us from. Of course, as you know, this is the AWS Cloud Security User Group training sessions. We've been having these sessions, of course, over the week or over the past few weeks. And these sessions are, of course, going to be on for the next coming weeks as well. But today we will be discussing on a very interesting topic, right? We'll be discussing on a very interesting topic, and we have a very important guest speaker in the house, right? Um, if you've been present in our community day series or you've attended our community days live sessions, of course, I know you must have met this speaker, but of course, she leads a very important section of the AWS community social media team. She's not also just a social media manager, she's also a dev SRE engineer, right? But of course, I would just give you a brief intro into who our speaker for today is, right? She's none other than God's Time Chisom. Wow. She's a senior DevOps and a site reliability engineer um, who is also into cloud infrastructure consultancy. She's a trainer, community leader with over 7 years of experience in the cloud native technologies. She's also into fintech infrastructure, Kubernetes, CI/CD automation, and platform engineering. She specializes in designing, deploying, and managing scalable cloud solutions across AWS and, of course, other cloud platforms. And she derives joy in helping, organizations build reliable and secure and high-performing systems. Her expertise cover DevOps engineering, cloud security, infrastructure automation, observability, incident management, and platform reliability. One other thing you need to know about God's Time Chisom is that she's very passionate about community and building the next generation of techies. You can always find her in our community events like the AWS Cloud Security User Group, She Code Africa Lagos, Hands On DevOps Community, and of course, many more. Without further ado, I would be introducing the topic and, of course, bringing the speaker on stage. This topic, like I mentioned, is quite interesting. It's observability and SRE on AWS using CloudWatch plus X-Ray plus OpenTelemetry. And of course, there's no other person suitable and knowledgeable enough to take us on this topic than God's Time Chisom. Hello, Chisom. How are you doing today? Hello, Chisom. Your mic is muted. How are you doing today?
Hello, can you hear me?
Yes, I can hear you. How are you doing today?
Hi. Uh, I'm doing well, and you? How are you doing?
I'm doing great. I'm doing great. It's been a while. I got to see your face, right? I mean, amazing work, I must say, you're doing in the community. And of course, this is just one of those things we see your hands in, right? And of course, I have my
Yeah.
notepad and my jotter here, and I'm just listening in and trying to jot on what I'm going to learn on today. But before I give you the stage, I see one of my very humble friends, somebody I've known a very long time, and I just want to give a shout out to him. Yemisi, how are you doing? Yeah, Yemisi, it's been a while. I think it's been over maybe 10 years. Yeah, so you can see him there. He's saying hi. So shout out to Yemisi. Good work, good God work. I see you're doing really, really a lot on AWS. So shout out to you. And now I'm going to be back to the screen to welcome Chisom once again. And Chisom, this is an amazing topic. I hope to really, really learn a lot. And of course, looking forward to the demos you're going to be running. And maybe I can be one of the winners for tonight. What do you think about that?
Okay. Let's see how it goes. But I know you're exempted from winning.
All right, let me not waste so much time because I know you have a lot to take on. I will just give you the space now to proceed with your training.
Yeah.
All right, then. Cheers.
Okay. Let me see if I can share my screen. My screen. Let me know when you can see it. Okay. Is my screen up? Okay. Can anyone see my screen? You can let me know in the chat if you can see my screen.
Yes, Chisom, I can see your screen. Yes, I can see your screen. It's up now.
Okay, thank you. So, guys,
Okay.
today we're looking into observability. Hold on. Okay, we're looking into observability with AWS, and we will be visiting what we will be revisiting what observability is. I know the keyword SRE has cut across a lot of things we do today. Monitoring has cut across a lot of things we do today. So we're looking into these terms. What does it really mean, and how can we actually instrument this into our day to day? So today we know that observability is not just a keyword, it's something that you as a cloud engineer or a DevOps engineer should be aware of. So if there is an application behind whatever you're doing, or even an infrastructure behind whatever you're doing, or what kind of work, any kind of work you're doing, or even data, right, you want to be able to observe, you want to be able to know what is happening. So that takes us to what an XRE is, understanding the concept of site reliability engineering. Also, we're going to look at CloudWatch. I know CloudWatch is very common for most of you use AWS for a couple of things. We're also going to then dive deep into X-ray and OpenTelemetry to see what these things are and how they can be useful to us as engineers. So let's even start with observability. So when you hear the word observability, I've had a couple of questions on what is observability, how is it different from monitoring. So the word observability is your ability to understand what is going on in your system, be it an infrastructure or an application. You want to understand what is happening, and when you eventually understand what is happening, you want to understand why. why is this happening, and then you want to dive in into fixing it. So when you're doing these three things, what you're doing is actually observability. But when you're just understanding what is happening, okay, I can see the CPU spike is 99%. That is just monitoring. You just have access to monitor the app. You're not really doing observability. So when you're doing observability, you know what, you know the why, and you also have an insight on how to fix it. So let's dive deep more into this. So there are three main pillars of observability. And first off, you talk of the metrics. So metrics are the one that we're very conversant with, which are quantitative measurements, CPU usage, CPU utilization, memory utilization. Is the memory utilized, or are we on gauge, latency? All of that are factored in as metrics, even for infrastructure, not just applications. So you can really get metrics around your app. Now, when you want to detail down, you then start talking about logs. So the detailed record of events that is happening. So logs are different from your metrics. For CPU, it can just show you the metrics of your CPU at that particular time may be at 99%, and you're wondering what is really happening. But logs will detail down to you what how these things, the series of events that has been occurring in your CPU, whether it is related to the metric spike that you're seeing or not. So logs will show you like series of events. Okay, the a lot of services was turned up and that led to the spike, or even when it doesn't relate to the spike you're tracing, right? Then we move down into tracing. So tracing is that part that completes your observability goal. So when you're able to do your tracing, here you're seeing the request flow. Say I'm trying to find out why my CPU is high. I'm able to see the last event that occurred before my CPU spiked to 99%. I'm able to see what happened before then, more like a trace down. So it gives you that step to step occurrence of events. So we, in this case, I would just call it a request flow. So how these requests are going before you hit that peak that you're trying to monitor. So these three guys are the three main pillars of observability. And when you have them, you'll be able to work better, be it infrastructure or be it an application. Okay, so let's look deep into site reliability engineering. What exactly is site reliability engineering? So this, I would define it as the approach to operations that applies to software engineering to mix operations and software engineering together. You get what I call site reliability engineering, because now you're not just doing, you're doing the dev. Remember, we said DevOps is dev and operation. So XRE also brings together those approach of operations together with software engineering principle. However, the focus in this case is reliability and what the system is expected to do. Is this system really doing what is expected to do? Then we want to understand scalability. We want to handle increase in load. We want to handle decrease in load. We want to be able to handle scalability. We want to go up and down when needed, right? We also want to focus on performance. So you can't talk about reliability without talking about performance. So if your system is not performing at its optimal level, or what I would call you're not hitting your SLA goals, your system is not reliable. So we want to know how fast is the system, how good is your system performing. Then we want to talk about cost efficiency. So when you're able to capture these four guys, your SRE goal is in check, right? And reliability of a system, however you want to measure it, you will still come back to these four guys. Is the system reliable? Is it scalable? Is performance on point? Are you cost effective? So these are the four main pillars. So I'm not going to, there are actually other facts around SREs, but because of time, I'm not going to dive deep into those aspects. But I want you to engineering as that part of DevOps or that part of software engineering that focuses on these four major things. Okay, so let's look at our popular guy, which is CloudWatch. A lot of us know today what CloudWatch do. In fact, from the first time you spin up EC2 in AWS, the next thing you will be seeing is cloud log events. Cloud log will be telling you, showing you some metrics. Excuse me. Cloud log will show you some metrics, how this is performing, what and what is going on within your EC2. So you see those small, small dashboard beside at the down part or monitoring part of your EC2. That's actually CloudWatch performing, because CloudWatch is native to AWS. So even without you having to do anything, it just starts showing you metrics. So what is CloudWatch? CloudWatch is a monitoring and observability service that collects, tracks, and analyzes metrics, logs, and events from your AWS services and application, AWS resources and application. So for CloudWatch, there are some key points that you should know that CloudWatch handles for you. It gives you metrics. And when you talk about metrics, you're talking about, remember, I've talked about quantitative measurements. You want to see percentage of this utilization and that utilization. So CloudWatch is default, shows you the default metrics for most services. Some you need to enable CloudWatch monitoring, but in most services, it's already enabled by default. So CloudWatch also gives you log. But now when you want to see the logs, you have to go the extra mile. You have to really go into the CloudWatch dashboard itself to really see logs. So yeah, most people wonder if CloudWatch actually instruments logs. Yeah, it does. It shows you logs of what's happening. And when you want more insight, you can enable more. So yeah, it gives you logs as well, which are more like detailed events happening in that application. Beyond that, CloudWatch also gives you dashboard. I believe we've all seen a CloudWatch dashboard, those small, small tips. So if you're not viewing it from the main CloudWatch board, if you're viewing from EC2, for instance, you would see the small, small dashboard that shows you what's happening on your EC2, giving you a visual representation of your metrics. And also you can do some alarms and alerting with CloudWatch. So these are like automated notification. You want to say, hey, CloudWatch, when this CPU is out or is maxed out, please send me an email. You want to instrument that through SNS and to send you these emails when something is happening within CloudWatch, right? Or if alarm on any other resource, be it your RDS database, you can also instrument CloudWatch to tell you when things are going wrong within that resource. So yeah, CloudWatch covers these four guys for you. So let's move on. Then we talk about SRE, which is where we are moving into. I know a lot of us may have heard, but have not really practically looked into SRE and what it does. So SRE is that part of AWS monitoring. Currently, they've moved SRE into CloudWatch dashboard. So you now see your APM within CloudWatch dashboard, right? Yeah, it's CloudWatch dashboard. Before now, S3 has its own dashboard, but yeah, S3 is that part of that AWS services that gives you distributed tracing. And when we talk about tracing, this is common with application performance monitoring. So where you see the step-to-step event of what is happening, and there are some four, or will I say, yeah, four components that are common with S-Ray. You talk about your service map. So service map, today, say I have a very big service that maybe an e-commerce website. There are line, there are different services that comes together to make up that e-commerce. So there is the database. If it's a microservice, there are like five or more services, maybe the payment service, the this service, that service. They all come together to make up that e-commerce application that you're using. So when this is instrumented into S-Ray, you're able to see how it connects. Okay, how the load balancer speaks to CloudWatch first, speaks to Cloudflare, the CDN first. From there, it moves to maybe your front end. From there, it moves to another service. So this gives you like that service map. So your service map is your virtual representation of that architectural structure of the application. So this helps you a lot when you're doing the SRE work, right? You're able to see, oh, this is breaching here, or maybe the connection from the load balancer to the front end is where the error is happening. You're able to now drill down better with your service map. So service maps just gives you that first insight into what you're about to do. Next, we talk about tracing, which, yeah, we know that you can actually get tracing. Okay, let's move on when we get there. So, yeah, tracing gives you a complete record of events. So, how is this occurring? When you have, which gives you a graphical interface, right? You want to see it in the log side of things. You want to see the event flow. Then you go down into tracing. So, X-ray gives you tracing, gives you more richer tracing than CloudWatch will do, right? So tracing contains all those segments, how this and that comes together, the events, series of events that occur. Say someone eventually paid for an item on your e-commerce website. How did they get to payment? Maybe at the point of payment, they received an error. Most monitoring tools will just show you that there is an error on the service flow. That's where tracing comes in. So tracing gives you that step-to-step guide of what is happening before you eventually hit the error point, right? So let's see more around S-ray. So within S-ray as well, we have what is called segments. So these segments are record created by S-ray to allow you understand both timing, status of things, resources information. So it gives you that child to parent relationship form of the trace. So it groups your tracing into segment, into what we call segment. So segment represents like a group of thing. It helps you organize, or it kind of help you organize your traces so that it's not just scattered everywhere. And again, we have sampling. So sampling, to me, I would call it that part of S-ray that helps you reduce an overhead. And what do I mean by that? Instead of you to push all your logs or instrument everything happening into S-ray, with the use of sampling, you can now streamline what you want to see. It helps you streamline, like get a percentage of what should be pushed to X-ray, instead of, because it can be a lot. And there are sometimes, if your sampling is not done well, it gives you a whole lot of things, irrelevant things into your tracing that you don't necessarily need. So sampling helps a lot, and by default, in 5%, it takes more of the 5% from your request. And what I mean by 5%, if your log has, of course, logs are always plenty. If series of events it can find is like, let's say 100, it groups out the very that details down what your application error is likely going to be. So this is just to help reduce what you're pushing into S3. All right, let's go further. Yeah, so I almost spoke about OpenTelemetry before I came in there. So yeah, OpenTelemetry on its own side is an open source standard for instrumenting telemetry data. And what are those telemetry data? We talk about the logs, the metrics, and the traces. So these things are already existing in your application. You can use OpenTelemetry, which is more of a way you want to instrument those logs. You can use OpenTelemetry now to fetch those your log. It's not, I wouldn't say it's a tool, but it's a standard whereby you're using to collect data from your application. So in this side, we're going to see how we can enable it, and it's X-ray would use that process to collect data from whatever it can receive from CloudWatch. And there are also other tools. So it uses what we call collectors. So depending on how your application is instrumented, you may want to do a manual instrumentation. What do I mean by that? So you want to really write some code to tell it, okay, sync with my app, blah blah blah, import this into my app. So this is where the fight between most times SRE, DevOps, and the software engineer comes in, because assuming the software engineer has written his code and has pushed and everything is working fine, but now you want to instrument traces, you want to connect his application or her application into S-ray, for instance, there are some things you have to manually input into the code to allow S-ray read this. So either you want to do the manual instrumentation or you want to do the automated way. So by the automated way, you're installing some agents or exporters, as we can call it, into their app to fetch you those data. So you don't have to do so much, but just to connect the agent. However, you can also write the code manually to instrument those data into your app. So yeah, we have the instrumentation phase, then the collectors. This just help you gather the telemetry data from the application. Then the exporters help you send those data to wherever you want it to visualize it. So if you want to visualize it in CloudWatch or in S-Ray or even external tools, right? You can instrument to external tools like Datadog, like Grafana and the likes, right? So this just does the exporting part. So these are like three major phases for you to perform open telemetry within your app. So let's dive in into to see what these use cases of this sorry, am I going back? 1 minute. Okay, let me use this screen. So now I just tabled out these use cases so that we're able to understand this better before we go into demo. So first off, if your use case is to monitor CPU, memory, throughput, I would say go get your CloudWatch metrics in check. So the tool for you is CloudWatch metrics. I don't know if my screen is in line. Okay. So if you're doing more of you want to monitor your CPU, your this infrastructure, and you're more concerned around metrics, then CloudWatch can give you those metrics. You don't need to go deeper into hotel and the likes. Then, if you want to record application events, say this is a robust app, I want to know why my users are not doing this. You just want to see record of the whole logs. CloudWatch has that for you. So CloudWatch is your best, right? But if you want to see service flow, you want to see how this connects to this, how this is moving from here to here. Say even the sometimes when you are troubleshooting an error in an application, the end goal, which is the 500 you're troubleshooting, may not really be the issue at hand. It could just be that your application tried to reach an external API and was not able to reach it and had a timeout on that end. But on your app, you're just seeing a 500. So if you want to really trace down sys request flow as they are going, then you have to start looking at this. Now, if you want to understand what caused this, then the service map can show you that, because the service map at any point would show you where the breach started. It will give you like a red signal on that side. So just looking at the service map, you're able to see, oh, this is the dependency failing. Or you're able, even if it's not a failure, you're just able to see all the dependency connected. Say I have an app and I instrumented it to use maybe Paystack or any other payment service to accept payment for me, and I want to see that without the developer telling you that, you may not be able to know that, oh, this app is actually sending an API call to an external service. So for you to have that picture at hand, then S-ray service map will just give you that. Now, if I want to start instrumenting my code in a standard way to send me these traces to maybe a platform, then you start thinking open telemetry. And if alerting is a thing for you, if your use case is that you want, then there is CloudWatch alarms, which can help you do that. So let's go right into demo. I will be sharing another part of my screen so that we can demo all of this I've been talking about. One minute. Can anyone see my screen? Oh, I think I did not share. Hold on. Share screen. Okay, I want to believe you can
Yes,
see my screen
we
now.
can see your screen. Yeah,
All right,
we
so
can see your screen.
I'm
Yeah.
sharing CloudWatch. Yeah, I'm sharing CloudWatch. So before now, when you go to AWS, let me redo that. When you go to AWS services and search for X-ray, X-ray, you would see this guy. This one is under services X-ray, right? But today it's now. So if you see, it's trying to load the old dashboard, but then it will redirect me back to. So this is where the old dashboard starts, but it will redirect me back to CloudWatch. So that is why I wanted us to have a view of what's happening. So yeah, the main dashboard for S-Ray has been moved into CloudWatch. So we are still going to demo that. So this is where it is being infused. It is now into CloudWatch as your traces. So before now, your traces has its own entire dashboard. So we're more here to demo what we want to look at. So the demo just creates an application that allows us it creates an application that allows us have events, and then for now there is no application. I don't have any application, so it's going to create that application for us using CloudFormation. So it's going to set up all the infrastructure that we need. So I'm just going to use all the defaults and go next. However, if you have your own application, then you can pay attention to all of these metrics, all of this connection is trying to do here. So I'm just going to ask it to spin up that demo app for us so that we can use it to see what all that we've been talking about. So it's going to tell me, do I want to create all of this? Yes, let's create it. So it's trying to create me the stack, trying to do that deployment to create me all of this. I hope it to be fast. Okay, let's see. So one is complete. It's still working. Some are still in progress. Okay, we have just few left to go. So it's still in progress. So let's give it just few minutes. And okay, we can let's see how many is still in progress. Just two. Okay, so this is the load balancer and instance profile. Okay, while that is going on, let's see if we can see the application. I believe some has should have been created by now. Okay, it's not done yet. Okay. Okay, so while that is still coming up, now this here where we have APM gives us like a breakdown of most of our application of what is happening on AWS application monitoring. So here is the services where you would see list of your services that you have instrumented into AWS. So we can see that some of our apps are already coming up, though not yet complete, but two services has been created. And if you go to application map, you'll be able to see the service map we're talking about. So far here we have load balancer and Lambda. However, they are not yet done. It's not yet done. The demo is not yet complete yet. The stack creation. Let me refresh. So yeah, it's still in progress. But yeah, this is what your service map looks like. And in a more, let me bring up this. Where's my slide? Hold on. There is a service map I was trying to show us. Okay, I think. Okay, we'll see that's a complete one when we're done here. So the service map shows you this service connects. The connection lines are not yet showing here yet because the app is still creating. So it shows you all the services that is instrumented and how they connect to each other. Say DB is sitting somewhere here and this connects to the DB and DB connects to this. So that is just more of what your service map is all about. Then you're able to set what we call the SLO. So as an SRE, you should have what we call service level objective. What is your objective for this application? Do you want this application? What is your target goal? Do you want this? So in most cases, you hear things like 99.999 whatever, right? These are actually real time calculations of uptime using what we call service level indicators, and those indicators include both your metrics, your traces, and things happening within your event. Say if AWS tell you today that their SLA, which is the agreement they have with the customer, service level agreement, is a 9.99999, it means that they have calculated the number of downtime they can accommodate in a year and calculate it, and they have just a 0.000 or 0 point whatever downtime. So this have like a standard way of calculating it, so you don't just hear 99.99 and think they are just formulating numbers. No, they have what we call service level indicators, which they are going to use to measure that good request all over total of all your requests times 100 gives you that indicator. Say for instance, if I'm to use a very small app, an app sitting in an EC2 instance, for instance, and if we want to instrument the SLO for that app, we are going to find out the amount, how much of a downtime can we accommodate, which is more of our error budget in this case. If we say, okay, highest 5 minutes in a month, 5 minutes in a month, you have to calculate that, take out that 5 minutes from your SLO. That means you have already instrumented what your SLO should look like, meaning that in a whole month, which is a 30-day, you're only going to do a 30 minus 5 times 100, and that gives you, so this has like a full-blown calculation. You don't just come out and say 9.99.999 or 99.99 or even 99.7 or whatever. You must have done that calculation, measure it out within a specific timeline, and then when you start creating your SLO board, let's even see what that looks like. So if I say I want to create an SLO for a particular service, I choose the service I want to create for, say this my load balancer, and then it asks you of what kind of type, what type is it? You say, okay, this is a dependency, or this is an operation, my service operation. So you start selecting all of that. How does it receive traffic and all of that? You start selecting. Then it should take you into your metrics type. What's that metric you want to measure for this particular service? And you say, okay, I want to measure latency, or I want to measure availability. And you can start from there to start instrumenting. So if there was actually a load balancer that have been in place, it's going to populate that metrics and tell you that, okay, in the last 3 hours, this app have been up for 100%. So you have good requests for 100%. And it is from there, because this is a tool that has been instrumented already where your application is sitting, it's going to give you that metrics, and you can now decide from this metrics, I've been doing 100% for the last 3 hours. How much can I see in the last 1 month? You can now say, okay, in the last 1 month, you've been doing a 90%. So it's going to do that calculation based on the request that it has received. If in the last 30 days you've been doing a 90%, then it will not be fair for you to set up an SLO goal of 99.9, because you first hit your SLO before you can exceed it. So you can actually set, if in the last 30 days I've been doing a 90%, maybe I can set up a 90.1. If I hit that, I can then extend my SLO goal. So this is, I've moved to the next stage. So it now tells you, okay, I want to set up a goal of 99.1 or 90, for whatever. You can edit this in the last 30 days or 28 days. It's going to show you how you have gone, how far you have gone here. So assuming we have that load balancer in place and it has been there in the last 30 days, you see the gauge line. This gauge line is at 99 because I have 99 here. Say I have been doing a 90 and I set my SLO to 90.1. My gauge line is now at 90.1, right? So at any time that service is doing below that, you'll be seeing a red line. Maybe my service is now at 50. So that gives you a call to do better. When you're seeing that you're not hitting your SLO, this can actually be someone's KPI to ensure that whatever is making this service to drop from this 90.1, which we have hit in the last 30 days, whatever is making it to drop from there, I need to fix it. I need to find out how. I need to find out the what and the why, so I'm able to fix that issue. So once you're able to get that, and in the other hand, it's also showing you your error budget alongside. However, we're seeing a no data because we actually don't have a data at this moment. And if we eventually instrument an application, it's going to show us very little, maybe for today, right? So we may still not have enough data to set up this. So you can't just wake up in the morning and set up SLO. You should set up SLO from how your application is already performing. So if my application is doing so bad at 80%, maybe my first SLO target will be maybe an 80.1. Or if I want to set the goal so high, I can say, okay, let's do an 85. Since my application has been on 80, I want to improve the service, right? So having a well instrumented environment like this would now help you achieve that goal, because at every point you have your eyes on that application to see if it's dropping, if you're hitting your error budget so badly, if you're hitting the SLO or not. So you're able to see all of that and set up that goal for yourself. Okay, so let's see, I believe our app should be complete now. Yeah. So let's go back to services. We should have a lot more services now. Okay, we have 3. So this demo comes with 3. Let me refresh and be sure that's what we have. Okay, so we have 3 services. Let's get into the load balancer. This is the load balancer. Okay, so we can see that we don't have any metrics. As this app keeps being online, because this is happening right inside SRE, we're able to see both its dependencies, the logs, the traces, everything that has to do with this load balancer. This is just your normal load balancer, which by default you may not have so much detail around it. But here we're seeing everything happening. If the load balancer is experiencing latency, the SLI health check, and also you can create an SLO around it. The dependency, we can see that there is one dependency, and when you select it, it's going to show you what the dependency is. So we have a dependency that is going to ECS. So ECS will tell how, if ECS is doing badly, this app is likely going to do badly. Okay, this is ECS Instant ASJ. This is most likely a security group, right? So it's captured this as a dependency for this application. So let's see if we can actually visualize this application. What's the name? Score keep. Let me go here and search for it. ALB. Okay, so this is this new guy here sitting beautifully. Let's see the URL. So let's see if we can visualize the app itself. Whoops. Okay, let's see if it will load. Okay, this is taking a while. It's not loading. So it's a demo app. I'm not sure what they have inside the app actually. So going back to our metric check. So so far we're able to see 1 minute. So we're able to see an overview of whatever performance this, how many hits that's come to it. Then if you go into your service operation, you're able to see a runtime metrics. If there are actually if there are actually traffic hitting this load balancer, you will be able to see that performance check here. And this is beautiful because um, we just did cloud formation and it had to set up all of this. Imagine you're doing this on your own, an application you're syncing in for maybe a Git repo, and you're uploading it here. The instrumentation you have to do yourself, you would have to come down into, either you want to manually instrument it like we mentioned during the rundown of the slide, or you want to come back into your, try to do that setup yourself, understand the things you want to monitor within the application. If you want to monitor traces and all of that, and even instrument OpenTelemetry look like. So is this my network? This is just rolling for a long time. Okay, so here under settings we can see here it's asking us to enable OpenTelemetry. So this takes hotel metrics. So if you want this to give you queries using, whereby with OpenTelemetry you're able to make some search with PromptQL, which is the query language for hotel, right? When you instrument this, so why I'm showing us this, in most cases, if all your services are in AWS, you can just do the automatic process. You don't need to write a code or go into the developer's code to modify it. If all your services are sitting in AWS, you can just click and enable all of that, and you'll be set up for this. Okay, I can set up and maybe delete later, but then I'm also very cost conscious, right? So with this, just doing this alone, you have instrumented this load balancer or any app within this environment to be able to work with this. Then you can go down and enable more. You can then start creating service keys that would enable your app access whatever service it is. So if your app is sitting somewhere in an external service and you need those keys to be able to connect to them, you can do all of that from your setup. You can go into this is S-ray. You can go into S-ray traces and do all of the setup, the sampling rules. You want to set up how to sample your app, create a sampling rule for your app. So you would have to do that yourself, set up all of that yourself, select the particular service that you want, the service itself, wherever the service is sitting in AWS. You just do all of that from the settings here, instrument that app to be able to sync it so that when you come back into traces, you get more richer context to your app. And when you do it now, it doesn't just start showing up immediately. It takes maybe like a couple of 20 to 30 minutes. It starts syncing with what you have already, start populating, start learning your logs, how what has been happening, start learning the events that has been occurring in those services that you have instrumented, right? So it's not like a magic that you just set it up immediately and you start using it. But yeah, you can use it the same day. You can see those traces coming the same day. So this, I'm just trying to be fast. Wow, it's 6:55. Okay. So this, I'm just trying to show us what all of this look like so that when you eventually have a real application, you know where to go to set up things. So this also is for logs, and you do all your setup, how you want your application to respond, the kind of logs you want to see, the APM itself, what service you want to instrument. You do all of that. If your account is an organization type, maybe you can do it in organization wide, but this is just for this account. So anything you set up here, you set up hotel, all the services, if you select it to sync with all services, every service you set up will begin to instrument hotel into it. So let's even see what our service map look like if we have more richer map now. Okay. So you still have two, but then they are not yet instrumented. This is Lambda and this is the application itself. So if you click on instrument, it's now going to try to instrument it, connect them together. So they are still very much separated from another. And why this is very much important is that when they are properly instrumented, right, you begin to see how they connect to each other. Or because this is just two, this will either speak to this or maybe a reverse call. But I'm trying to get, there's an image that I pictured out. Let me see that image. The image kind of shows us what's okay. Yeah, this is the image I'm looking for. This is the image I'm looking for. I thought I added it to my slide. I don't know if we can see it yet. So now, first, how do all of this work together? If you have an application and you have done all the connection and instrumentation, Hotel takes that logs and at that telemetry data, be it logs or traces, send it through any channel that you want it to send to. If you want to just see it in CloudWatch, you can instrument it to view in CloudWatch. And in CloudWatch, you just see your logs and your metrics. If you're going through X-ray, you use the X-ray exporter and send it within X-ray. You're able to see traces and service map. If you're going through external services, you'll be able to see it in maybe Datadog. I use Datadog as an example here. So however, your app is sitting in AWS and you've done the instrumentation and bring them into one specific dashboard. So in CloudWatch, everything will just be seamless. You'll be able to see those small boxes. Let me even show us one. Those small boxes EC2 now. So if you go to EC2, without coming to CloudWatch dashboard, you'll be able to see the little small boards. I believe we know that what I'm talking about. You'll be able to see those small boards that shows you your application metrics itself. Let's see, do we have any service running? App set up this guide for us. Um, so if you scroll down here to monitoring, this is where you usually find that board. So I just want to believe it's able to capture that, since we just spin it up now. But most times you just need few minutes for you to start seeing the performance. Okay, it's loading, but most likely we're not going to have much richer data. So this is your application metrics, whatever this will show you with time. And this can be very useful because you can actually check based on days, weeks, months, 6 months ago, whatever months ago you're checking for. It's going to show you how this CPU or this EC2 instance has been doing. So you can see that our app was just set up a few minutes ago, and in the last, when it was set up, the percentage was at 22.1%, and currently it has gone down to more of 2%, 2.74%. So it's, the CPU is fine. You're able to see the network trace, the network packets, and all of that, even memory. And if you now want more detailed monitoring, it takes you to CloudWatch too, for you to see that. But then I don't want to instrument CloudWatch agent. So if you want logs, you can then instrument it to look to use a CloudWatch agent to scroll out logs, meaning aside from these metrics, I want to see events happening inside the application. So if you click on this, it goes to install CloudWatch agent inside that EC2 instance. Because they are all sitting in AWS, right? The installation and all of that will be very much simple. So you can see that for this instance, SSM agent is not active. So it's most likely not going to be able to SSH into the instance. So it needs SSM to be active. SSM is that how do I put it now? It helps you connect to your EC2 instance. It allows AWS services to connect. So you have to go and set up SSM for this instance. So once it's active and you click on install agent, it's going to go inside this instance and install CloudWatch agent, such that when you now go to CloudWatch to see the logs happening in this EC2 instance, you're able to see all of that. So at the moment, we talked about CloudWatch alarms. This is where you can set up that. Then we talked about how instrumented and installed that agent or that application. When you come into this log analytics, you'll be able to see different services that you have set up to scrape log from, and you're seeing the log groups, and you're able to see those log groups and view the logs from this dashboard. So at the moment, we have not installed any at all. We've not installed any agents. So there's most likely not going to be a log for us. However, by default, CloudWatch will give you metrics for your services because that doesn't require an agent. So these are the log groups I'm talking about. So for AWS Lambda, if there is any, I think this is an old app for me. Then this is the one we just did now. All the X-ray samples are from the application. So this is a database. Let's see if this has anything to show us. I don't remember what database is. Is it done today? 1 year ago. Wow. I'm not even aware this is existing. So this is going, if is exactly, so we're going to see these logs as it's happening, what's happened. Okay, there was a start in this event and this and this. However, this is not tracing. Tracing comes in more sweeter than this. I'm not sure we have anything happening on tracing, but then tracing gives you per event. Someone clicked, what are the end-to-end processes that has happened within this process? We don't have anything happening. Zero trace was retrieved. So we don't have any application that has been instrumented for tracing at the moment. So most likely we may not have anything on tracing, but tracing is more sweeter to work with when you're really looking for issue. Unlike logs, for logs you have to go through the log, each log entry you have to go into it one. And imagine, this is just very few. Imagine where you have millions of log, you may just be doing a search. Maybe you're searching by error and you want to see all the errors. However, tracing takes you line by. That is why we're talking about S-ray today, because S-ray gives you that tracing you're looking for. And much more, not just error tracing, but also events, transaction, and more richer tracings for what is happening on your app. Okay, at this moment I'm going to stop here. Our application didn't really have, the demo app didn't really have so much detail. I was hoping that it would come with already instrumented logs. So there's one request, and that one request, I believe it's that one I tried to call. Let's even see if that one request has anything. Did it show it as an error or not?
Awesome, awesome, awesome.
Oh, we've elapsed our time. Okay, so you can see that very well request we did, pointing here at a latency of over 6 milliseconds, 654. So it didn't really occur fast, and it captured that little resync we did on the load balancer. So imagine where you have much more than this happening within the application. You're able to see what is happening, if it occurred as an error and all of that. So yeah, I will stop here and take questions so far. Do we have questions on the chats?
Any questions? Any questions? Any questions for Chisholm? Does anyone have any questions for Chisholm? If you have questions, please drop them in the comment section. Because if you don't have questions, I have questions for you. I have questions for you. No one is actually um, posting any questions. All right. So to answer my questions, please go to kahoot.it. Kahoot.it, guys. Yeah. To answer my questions, please go to, yeah, I think it should be https this kahoot.it. Yeah, this one. Yeah, please go to this site, guys. Kahoot.it. And I am going to be sharing the pin code in a bit. Yeah, the pin code is 947.
Is there a price for the question?
Of course there is. Of course there is. 974436. So please go to https kahoot.it. So guys, please go to kahoot.it, and I have the pin displayed on the screen. I have the pin displayed on the screen. I'm not seeing anyone joining. I thought you all said you don't have any questions. It's time to answer my questions, guys. Yes, now I'm displaying the pin on the screen. And no one is joining. Is it that no one is ready to win any prize? Okay, I see Femi has joined in. No other person is joining. Is there no other person joining? Oh, I see Femi. Femi asked a question. He said he's watching on via YouTube. Is there a Zoom link? Right? We don't have a Zoom link, Femi. It's just on YouTube and LinkedIn. Freeman is in. So, guys, are we joining? So we have Femi, we have Freeman. Is it just these two we are going to allow to win the prizes? Oh, welcome, Des. Any other person joining? Awesome, Des. I see that. I see that, Des. Any other person joining? All right, I think we should start. Superstar, thank you for joining in. Let's start. I guess the rest would yeah. So we're starting, guys. All right, let's get ready. Why shouldn't you rely solely on X-ray sampling for debugging rare production failures? Can anyone answer why? Wow. No one picked any question. Interesting. All right, let's see. Oh, looks like
Are
is
you sure the couch is working
yeah,
properly?
I think it is. I think it is. Um, please let me know if you're having issues with the Kahoot, guys. Let me know if you're having any issues with the Kahoot, guys. All right. Proceeding to the next question. Your Lambda publishes 6 custom metrics per invocation, 100K invocations per day. AWS bill went from $300 to $2,400 per month. Why? Wow. So, Chisom, can you see your answer? I see it's working. All right. I see 3 people got the answers. Nice.
Yeah.
Nice. Wow. Yemisi seems to be topping the scoreboard. Awesome. Awesome. Followed by Freeman and Kalista. Interesting. And to the next question. X-ray shows all AWS calls succeeded. Lambda, DynamoDB, S3, but customer never receives confirmation email. What happened? What do you think happened, guys? Wow, we have 5 answers already. Wow. Looks like only one person got the correct answer. Let's see who is going to top the board. Wow, Yemisi is still leading. Nice. 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 Yemisi, keep it up. Followed by Freeman, Calista, Maxwell Cyber. Interesting. Interesting. All right, on to the second to the last question. CloudWatch alarm error rate greater than 1%. Triggers on day one, one error. Day five, one error. Day 20, 50% error rate in real outage. What would have happened, guys? Wow, four people got the answer. Awesome, awesome, awesome. Let's see if Yemisi will still be leading the board. Yemisi is still leading, but I saw a jump from Maxwell Cyber. Awesome, awesome, awesome. Well done, Yemisi. Now to the last question to determine the final winner.
That must be a cyber attack.
Add Datadog S-Water to existing OpenTelemetry setup, CloudWatch plus X-Ray, some metrics in Datadog, others missing. Why? 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 Wow. No one got the answer. Ah, I see. No one got the answer. Interesting. Well, let's see who is on the top board. Top three, Freeman. Kudos to Freeman. And to the second, Maxwell Cyber. And let's see who the winner is. Let me see. Congratulations.
Ooh,
Congratulations, Yemisi, for doing an
this
awesome job.
Maxwell really did a cyber attack.
I'm telling you. I just saw the guy came from nowhere and he's on the second he's on the list as the second. So kudos to Maxwell and of course congratulations to Yemisi for being the winner of this quiz. All right, guys. It's been absolutely awesome hosting you guys today. We are going to be having more series coming up next week, upper week, and of course we have lots of interesting topics packed for you all, right? So please look forward to our session coming up. Ensure to register for the session on Meetup, right? Once you are registered for the session on Meetup, you will get information about the topic, when it's going to be starting. But of course, definitely next week, 6 p.m. West African time, we are going to be live. So I'd like to thank Chisom for taking her time to explain this topic for us today. It was really, really interesting. Thank you once again for this session. And to everyone out there who took time to actually listen in, learn one or two things from this session, kudos to you guys. You're doing awesomely well. At this point in time, I would like to say thank you all for joining the session for today and see you all next week.